Hello students, today I have come up with the second part of P block elements. We were doing noble gases. Today also will continue with noble gases. Okay, today I will start with the compounds of xenon. Among the noble gases, xenon forms a maximum number of compounds. Xenon easily form compounds with the highly electronegative oxygen and fluorine. Oxygen and fluorine. Both of oxygen and fluorine are highly electronegative. They will easily attract electrons from xenon, thereby forming compounds with xenon. Okay? So, the xenon compounds are divided into three groups. Xenon compounds are divided into three groups. Xenon fluorides, xenon oxides, and xenon oxyfluorides. Okay, the xenon compounds are basically of three groups: xenon fluorides, xenon oxides, and xenon oxyfluorides. Today I will start with xenon fluorides. So first I will come to the three compounds. Xenon difluoride, xenon tetrafluoride, and xenon hexafluoride. First I will come to the preparation of these three compounds. Xenon fluorides can be easily prepared by the direct combination of xenon with fluorine at different conditions. Xenon plus fluorine in presence of catalyst nickel, temperature 673 Kelvin and pressure 1 bar results in the formation of xenon difluoride. Again, okay, remember one thing here: xenon and fluorine are in the ratio 1:3. Xenon plus fluorine, same catalyst is used, temperature 873 Kelvin and pressure 7 bar will form HCF4. Here xenon and fluorine are in the ratio 1:5. The next reaction, xenon plus fluorine in presence of nickel tube, temperature 573 Kelvin and pressure 60 to 70 bar will give xenon hexafluoride. Okay, so these compounds can be prepared by the direct combination of xenon and fluorine. Another process by which XeF6 or xenon hexafluoride can be prepared is the direct combination of xenon tetrafluoride and O2F2 at 143 Kelvin temperature to form XeF6 and oxygen. Okay, this is how the xenon fluorides are prepared. Now I'll come to the chemical reactions. Okay, these are the preparation. Now I'll come to the chemical reactions of xenon fluorides. The first reaction is reaction with fluoride ion acceptors. Now what are these fluoride ion acceptors? These are the substances which will accept fluoride ion from xenon fluorides. Means from any fluorides they will accept fluoride ions, but here xenon fluorides. The fluoride ion acceptors examples are phosphorus pentafluoride, antimony pentafluoride and arsenic pentafluoride. Now what happens, let us see. When xenon difluoride reacts with phosphorus pentafluoride, what will phosphorus pentafluoride do? It will accept a fluoride ion from XeF2. XeF2 has two fluoride ions. It will accept one of the two fluoride ions and will form PF6, and since it is accepting one fluoride ion, so PF6 minus. And what will happen to XeF2? It is losing one fluoride ion, so XeF plus. These are known as addition products or adducts. Okay. Here the PF5 is accepting one fluoride ion, resulting in the cationic species and fluoroanions. These are known as fluoroanions. Okay. Same type of reaction occurs here. One fluoride ion accepted by antimony pentafluoride will form XeF3 plus and SbF6 minus. This is also an adduct. Arsenic pentafluoride, XeF5 plus and AsF6 minus. Okay, these are the three adducts formed when xenon difluoride, xenon tetrafluoride and xenon hexafluoride reacts with the fluoride ion acceptors like PF5, SbF5 and AsF5. This is arsenic, this is antimony and this is phosphorus. Okay, next I'll come to the reaction with water. Reaction with water. Okay. If I will balance it, I am directly balancing the reactions. Remember one thing, that xenon difluoride reacts with water, but the hydrolysis process is slow. When xenon tetrafluoride reacts with water, disproportionation reaction occurs. And both xenon and xenon trioxide is formed. Along with that, HF is formed and oxygen. Disproportionation reaction occurs here in this case. Okay, and last is when, but this hydrolysis is violent. Next is the reaction with xenon hexafluoride. Okay, here also the hydrolysis is violent. So these are just the reactions which you have to learn. There is nothing to understand in this part, that is the reaction with water. Okay, these are the three reactions by which xenon fluorides react with water. The next I will come to the reaction where xenon fluoride acts as fluorinating agent. Xenon fluoride acts as fluorinating agent. How? It reacts with platinum to form platinum tetrafluoride and xenon. Again, it reacts with SF4, that is sulfur tetrafluoride. To give SF6 and xenon. Means xenon fluorides act as fluorinating agent. The fluorides from xenon fluoride will be added to the substance to which these xenon fluorides are added. Here platinum reacts with xenon fluoride to form platinum fluoride and xenon. Here sulfur tetrafluoride reacts with xenon tetrafluoride to form sulfur hexafluoride and xenon. Okay, so here xenon acts as fluorinating agent. Okay, and the last reaction is the reaction where xenon fluorides act as oxidizing agents. Here it will oxidize chloride ion to chlorine and iodide to iodine. Let's come to the reactions. Okay. Next reaction is with Ki. Okay. See, in these cases HCl means Cl minus and this is oxidized to chlorine. Here Ki means I minus, this is oxidized to iodine. Okay. These are more or less the reaction of xenon fluorides. Now I will come to the most important part, that is the structures of the xenon fluorides. The structures. Among them, the first is xenon difluoride. Okay, xenon in the ground state. We all know that it is 5s, 5p and 5d, 2 electrons and 6 electrons. But xenon in the excited state. In excited state means xenon in xenon difluoride, means in presence of two fluoride ions. Okay. One electron from this p orbital will go to 5d orbital. So the two fluorides will give one electrons, forming two bonds of Xe with the two fluoride ions. Here the p orbital of fluoride combines with the p orbital of xenon to form p-pi bond, sigma bond. P-pi sigma bond. And here the p orbital of fluorine reacts with the d orbital of xenon to form p-pi sigma bond. Here p-pi and another p-pi. So the hybridization will be sp3d, one s orbital 3p and 1d, sp3d. So the ideal geometry for sp3d is trigonal bipyramidal. But what happens in the structure? Let's see. The three lone pairs and the two fluorine atoms. So there are three lone pairs, and xenon with the two fluorine atoms is in the linear position. Since the other positions are occupied by lone pairs, so the actual structure is, or actual geometry is, linear. Okay, in your exam you have to show this hybridization, you have to write the ideal geometry, you have to tell that how many lone pairs are present, and for that the actual geometry changes. This you have to, the entire part you have to show. Whatever I have shown on the board, you have to show in your exams. Okay. Next I will come to xenon tetrafluoride. Here another electron will get shifted to the d orbital, and so here another fluorine atom and here another fluorine atom will form the bond S 3p orbitals, 2d orbitals, sp3d2. The ideal geometry for sp3d2 is octahedral. So let's see the structure at first. Octahedral. And two lone pairs. See, the actual ideal geometry is octahedral, but there are two lone pairs at the two axial positions, and the equatorial position consists of 5 fluorine atoms. So the actual geometry is square planar. Okay. The next is Xe F6, and the ground state remains same for all the three. Here another electron will be shifted to the d orbital. So two other fluorine atoms will form two bonds, 1s, 3p and 3d, sp3, d3. So the ideal structure will be pentagonal bipyramidal. Pentagonal bipyramidal. So let's draw the structure at first. Pentagonal bipyramidal. Okay, this is the structure of pentagonal bipyramidal here, but there is a lone pair of electron. So because of this one lone pair of electron, the actual structure will differ and the actual structure will be distorted octahedral. Okay, these are more or less about the structures of and preparation and reactions of xenon fluorides. In the next video, I will continue with xenon oxides and xenon oxyfluorides. Thank you.